OpenAI has done it again. When you think they can't get any more innovative, they blow everyone else out of the water. This company is like the biggest unicorn of them all. With the inception of generative AI, we had Dolly from them, and that was competing with Midjourney. And then something like Runway ML came out, and that was text to video. It was the first time we saw text to video, and it was pretty mind-blowing then. But now there's Sora. Sora has just come out and it is outstanding. I really, really want to get a chance to test it, but they are using precautions and making sure that only specific selected people get to use Sora because there are risks associated and it is extremely realistic. This is Sora creating video from text. It's an AI model that can create realistic and imaginative scenes from text instructions. So this doesn't just do realistic video, but it also does imaginative and cartoony video if you'd like. Let's check it out. All right, let's read the technical report. Video generation models as world simulators. We explore large-scale training of generative models on video data. Specifically, we train text conditional diffusion models jointly on video and images of variable durations, resolutions, and aspect ratios. We leverage a transformer architecture that operates on space-time patches of video and image latent codes. Our largest model, Sora, is capable of generating a minute of high fidelity video. Our results suggest that scaling video generation models is a promising path towards building general purpose simulators of the physical world. Ooh, it looks like we're getting to Black Mirror status pretty quick. In the last season of Black Mirror, there was a woman who saw herself on a streaming platform, and it was called Joan is Awful, and her name was Joan. And she was curious about it, so she saw the show, and it was like a play-by-play of her actual life. What had happened a few hours earlier would be portrayed on the screen, very dramatized. So it's almost as if in the future we can see this actually happening with something like this. And I could even go further because if somebody has something like Neuralink, it's essentially going to be recording people's mental images. So, for example, their views in their brain from their eyes could be recorded, and then it could be like a real play by play and everything they're thinking as well. It's getting to be definitely an interesting world that we're coming into. And I feel like if we have really, really good ethics in place and really good regulations, then these kinds of things could be safer or mitigated. Right now, I don't think regulations are keeping up, and I think it's going to be definitely interesting to see what happens. So let's just look at this. Oh my God. It's already so good. Like when I'm looking at this video, it looks like a real woman. These look like real people in the background. It's like a slow-mo version of a real model walking. And look at the definition on her face. Look at the like the dimples and the texture. It's not perfect. And usually when you think of like AI generated stuff, it is perfect. But here you can see little freckles and dimples and texture that isn't perfect, which makes it more realistic and more human. Man, it's outstanding, really. Just with some text, you can generate something like this. Honestly, actors should be worried, and anybody in the movie industry should be worried because soon this is going to eradicate the entire industry. Say goodbye to Hollywood, everyone. It's wild. This technical report focuses on our method for turning visual data of all types into unified representation that enables large-scale training of generative models and qualitative evaluation of Sora's capabilities and limitations, model and implementation details are not included in this report. Much prior work has studied generative modeling of video data using a variety of methods, including recurring networks, generative adversarial networks, autoregressive transformers, and diffusion models. These works often focus on a narrow category of visual data, on shorter videos, or on videos of a fixed size. Sora is a generalist model of visual data. It can generate videos and images spanning diverse durations, aspect ratios, and resolutions up to a full minute of high definition video. I mean, if you could get a full minute of high definition video, you could just make a bunch of these and then stitch them together and edit them. The human attention span is only about 8 seconds, or maybe even less than that now, which is the attention span of a goldfish. And now with this, you'll be able to make an entire short movie because all you need are these 2 second, 3 second clips. And then you can stitch those together to make an entire narrative. It's fascinating. So turning visual data into patches. We take inspiration from large language models, which acquire generalist capabilities by training on internet-scale data. The success of the large language model paradigm is enabled in part by the use of tokens that elegantly unify diverse modalities of text, code, math, and various natural languages. In this work, we consider how generative models of visual data can inherit such benefits. Whereas LLMs, or large language models, have text tokens, Sora has visual patches. Patches have previously been shown to be an effective representation for models of visual data. We find that patches are highly scalable and effective representations for training generative models on diverse types of video and image. Interesting. I'm not going to pretend to know what that means, but we will probably look into it. I'll have to do some research and then like share exactly what that means and how it's done. They have a visual representation here, so it looks like many videos are layered and then it goes through a video encoder and it's turned into some sort of 3D version of that. Again, not going to pretend to know exactly what this is or how it works. I'm just fascinated and I can't wait to learn more. So at a high level, we turn video into patches by first compressing the videos into a lower dimensional latent space, and subsequently decomposing the representation into space-time patches. Super interesting. Have you ever seen like the way Midjourney makes images? It's like this fuzzy blur and it just continues to become less fuzzy until this like final processing of it, and then it just looks extremely uber realistic. Um, this might be similar to that. Video compression network. We train a network that reduces the dimensionality of visual data. This network takes raw video as input and outputs a latent representation that is compressed both temporally and spatially. Sora is trained on and subsequently generates videos within its compressed latent space. We also train a corresponding decoder model that maps generated latents back into pixel space. Ooh, very interesting. This is getting super technical super quick. Space-time latent patches. Given a compressed input video, we extract a sequence of space-time patches which act as transformer tokens. This scheme works for images too, since images are just videos with a single frame. Our patch-based representation enables Sora to train on videos and images of variable resolutions, durations, and aspect ratios. At inference time, we can control the size of generated videos by arranging randomly initiated patches in an appropriately sized grid. I guess that just means that you can change the aspect ratio and you can have, you know, vertical and horizontal video. Scale transformers for video generation. Sora is a diffusion model. Given input noisy patches, and conditioning information like text prompts. It's trained to predict the original clean patches. Importantly, Sora is a diffusion transformer. Transformers have demonstrated remarkable scaling properties across a variety of domains, including language modeling, computer vision, and image generation. This visual representation is showing exactly like that mid-journey fuzzy to very crisp and clear visual that I was talking about before. In this work, we find that diffusion transformers scale effectively as video models as well. Below, we show a comparison of video samples with fixed seeds and input as training progresses. Sample quality improves markedly as training compute increases. Okay, so very interesting. So there's base compute and it looks like a weird shape-shifting blob of a dog. And then with 4 times compute, it's looking like a blurry but realistic dog with person in the background. And with 32 time compute, it's crisp, it's clear, it looks very, very realistic. Looks like a professional camera is shooting that. Wow. Variable durations, resolutions, aspect ratios. Past approaches to image and video generation typically resize, crop, or trim videos to a standard size. 4-second videos at 20 or 256 times 256 resolution. We find that instead training on data at its native size provides several benefits. Sampling flexibility. Sora can sample widescreen 9020 times 1080, which is this video, and vertical, same. It's basically what YouTube and your phone uses, and everything in between. This lets Sora create content for different devices directly at their native aspect ratios. It can also let us quickly prototype content at lower size before generating a full resolution, all with the same model. Ooh. Now, being able to prototype something before full generation, that's super, super amazing. Usually, you currently have to spend credits to generate it to then see if it works or not. And a lot of times, if it's something that takes many tries, you're just spending money without reason because it's not actually going to work. This is something that I didn't really enjoy in things like Synthesia and HeyGen, where you really had to pay the price just to see if the video would work with the audio and visual. These turtles are exceptional, especially this one in the middle right here. I'm just so impressed. Improved framing and composition. We empirically find that training on videos at their native aspect ratio improves composition and framing. We compare Sora against the version of our model that crops all training videos to be square, which is a common practice when training generative models. The model trained on the square top left sometimes generates videos where the subject is only partially in view. In comparison, videos from Sora on the right have improved framing. Language understanding. Training text to video generation systems requires a large amount of video with corresponding text captions. We apply the recaptioning technique to introduce DALL-E 3 to videos. We first train a highly descriptive captioner model and then use it to produce text captions for all videos in our training set. We find that training only highly descriptive video captions improves text fidelity as well as the overall quality of videos. Similar to DALL-E 3, we also leverage GPT to turn short user prompts into longer detailed captions that are sent to the video model. This enables Sora to generate high quality videos that accurately follow user prompts. Amazing. So if you're looking at these prompts on the left, they're not very descriptive at all. A woman wearing a green dress and a sun hat, taking a pleasant stroll in Mumbai, India, during a beautiful sunset. And this is the type of output that you can see. And the output is exceptional. It's very, very realistic with not a very detailed prompt at all. So it's impressive. It's honestly really crazy. Now, if Sora can get to the point where it can generate consistent output, like if you have a character that you would like to be consistently the same character in many scenes and in many different scenarios, this will really, really help it stand out. With image generation right now, you can take the image and then you can train a separate model on a particular object in the image that you want recreated over and over and over again. This could be like this green dress, for example. If you have a green dress that you want portrayed in many different scenes or a specific character, you can tokenize and train a model specifically on that green dress or on that face that you want to use over and over. Let's move on. All right, so prompting with images and videos. All of the results above and, ooh, okay. All of the results above and in our landing page show text to video examples, but Sora can also be prompted with other inputs, such as pre-existing images or video. This capability enables Sora to perform a wide range of image and video editing tasks, creating perfectly looping videos, animating static images, extending videos forward or backwards in time, etc. Animating dolly images. Sora is capable of generating videos provided an image and prompt as input. Below, we show an example of videos generated based on Dolly 2 and Dolly 3 images. Oh, there's the doggy. It's a Shiba Inu wearing a beret and a black turtleneck that they've animated. And then this little monster cartoon that's also animated, and it's actually really good. Let's keep going. Oh my gosh. Okay, so this surfing video is insane. It's so crazy. This would be a really good scene from Night at the Museum. All right. Extending generated videos. Sora is also capable of extending videos either forward or backward in time. Below are 4 videos that were all extended backward in time, starting from a segment of a generated video. As a result, each of the 4 videos starts different from the others, yet all 4 videos lead to the same ending. Cool. We can use this method to extend a video both forward and backward, or to produce a seamless infinite loop. Very cool. And video to video editing. Diffusion models have enabled a plethora of methods for editing images and videos from text prompts. Below, we apply one of these methods, SD-edit, to Sora. This technique enables Sora to transform the styles and environments of input videos zero shot. So you can change the setting with the same object. Connecting videos. We can also use Sora to gradually interpolate between 2 input videos, creating seamless transitions between videos with entirely different subjects and scene compositions. In the examples below, the videos in the center interpolate between the corresponding videos on the left and right. Okay. Oh, cool. So they can switch. You can add different elements to a video, essentially. The model can generate images of variable sizes up to 2048 times 2048 resolution. Yeah, this is really realistic. The rest are a little bit cartoony, but still good. Emerging simulation capabilities. We find that video models exhibit a number of interesting emerging capabilities when trained at scale. These capabilities enable Sora to stimulate some aspects of people and animals and environments from the physical world. These properties emerge without any explicit inductive basis for 3D objects, etc. They are purely phenomena of scale. 3D consistency. Oh, here we go. Sora can generate videos with dynamic camera motion. As the camera shifts and rotates, people and scene elements move consistently through 3-dimensional space. Okay, that's pretty amazing. So it wasn't talking about 3D consistency in terms of the objects in different scenes and different generations, but it is talking about being able to move the camera and having the people or the objects consistently stay in frame with the movement. which is pretty huge itself. Okay, let's keep going. Long-range coherence and object permanence. A significant challenge for video generation systems has been maintaining temporal consistency when sampling long videos. We find that Sora is often, though not always, able to effectively model both short and long-range dependencies. For example, our model can persist people, animals, and objects even when they are occluded or leave the frame. Likewise, it can generate multiple shots of the same character in a single sample, maintaining their appearance throughout the video. That's important. Interacting with the world. Sora can sometimes simulate actions that affect the state of the world in simple ways. For example, a painter can leave a new stroke along a canvas that persists over time, or a man can eat a burger and leave bite marks. Simulating digital worlds. Sora is also capable to stimulate artificial processes. One example is video games. Sora can simultaneously control the player in Minecraft with a basic policy while also rendering the world and its dynamics in high fidelity. These capabilities can be elicited zero shot by prompting Sora with captions mentioning Minecraft. These capabilities suggest that continued scaling of video models is a promising path toward the development of highly capable simulators of the physical and digital world, and the objects, animals, and people that live within them.
Sora's limitations really lie in the physics of the natural world. Things like breaking glass or having things spill properly. But this is just wildly amazing and such a step forward.
All right. If we are really in a simulation, I imagine this to be the way it's done. Our world is about to get really weird real quick. So many things come to mind when I'm looking at this, and I already don't trust things in videos, and I already don't trust what I see in videos. But now, after things like face fusion, where you can just switch people's faces, or something like this, literally everything could just be generated at this point. If you're feeling like something is doubtful or something might not be true, I mean, chances are it's going to be generated. We believe the capabilities Sora has today demonstrates that continued scaling of video models is a promising path towards the development of capable simulators of the physical and digital world and the objects, animals, and people that live within them. Ooh, okay, this was a fantastic read and very stimulating. So, from this, I can already imagine the world of simulated reality in the future. So, instead of taking part of a video game, you're going to be completely encapsulated by a video game that will be generating in real time, which is very interesting because it's kind of like how life works. You are essentially walking around and being controlled by this thing that you have in your skull through lenses, which are called eyes, and everything around you is manifesting in real time. And the only way that you know this is real is based on your consciousness. So, this is almost like a recreation of the way that we see in life. I think that's getting a little bit metaphysical there, and it might not make sense to everyone. I have very vivid imagination, but I can just see it very clearly. And this stuff is wild. It's so exciting. Yet, also, I guess it really could be dangerous depending on how people use it, right? That's why ethics, that's why programming with morals and ethics, weaving that into the fabric of the creation of these things is important. Really training populations to respect these types of innovations and to use them for good because while they could be wildly inspiring and create so many inspirational and creative videos, it could also lead to something really destructive if people were to believe something that is not true, that is being said is true. right? I do think that watermarks on these things are going to be super important and just a way of identifying these types of um, generated videos and making sure that people know that this was made with AI. Um, Again, if there are bad actors, they might not disclose some of those things. And people are creating new models every single day with various capabilities. And even though OpenAI is one of those companies that really, really thinks of the ethics whenever they're making something, and they do have a lot of risk mitigation within their products, they don't give you the full extent of what it can do. There are people that are making their own models without those restrictions. It can be amazing if somebody is a really good person using it. However, it is very risky for people who are not using it wisely or don't have the same moral guidance or moral compass inside of themselves. And I'm super, super excited to see how this plays out for our future. We're in some fun times. Subscribe if you want to see more stuff about artificial intelligence. I guess we'll see where all of these innovations lead. See ya!